So find the Fourier transform of fx is equal to, okay, so I'll take it to be 0, let's say half, let's say e to the power minus x, right? And this is x less than 0, this is x equal to 0, this is x greater than 0. So we have it as equal to 0. It doesn't make much of a sense when we're talking about the integration. So this part you can really ignore, okay? And you have to prove. So most of the times, if I'm asking you a question on Fourier transform, the chances are that I'll do give you a take to it, and I will tell you that hence proof this and that. Okay, so that's important. So this is cos of kx plus a sine of kx divided by 1 plus k square, okay, dx, okay, is equal to 0. Is equal to maybe 0 pi by 2 and pi e to the power minus x. So if you follow what we did in the morning class, I think this one you can easily guess, okay, why there is a pi by 2. That is, on the other side we'll be having something with 1 by pi, then it is cross multiplied and that's it, okay. So that way you should be able to do it. Okay, so this is a problem which you should solve, okay. I'm not going to do it. I'm going to shift to the next topic, which is actually nothing but the Fourier, sine and cosine transform, okay. So just consider this as a homework. I'm going to ask you in the next class. So I would like you to do it, keep it with you, okay. Never know that I might ask you in this in the exam also. So next is Fourier sine and cosine transform. So before I give you the relation directly, I can give you the relation and you can easily remember it. There is a way of remembering this relation. Okay, this works most of the times. So when you write down your Fourier transform, and if you write it down as, let's say, this 1 by root over by integration of minus infinity to plus infinity e to the power I k f x dx. Right, that's a Fourier transform. And what we can do now is we can actually divide it into the sine term and the cosine term. Okay, we've done it also, and that's the reason in some of the problems I've done it just to show you. And this example we can actually take it. So I can take it to be nothing but like this: cos of kx, and then we have got fx dx first term, and then plus I can take one more term divided by root over of 2 pi integration of minus infinity to plus infinity, and then I sine of kx fx dx. Okay, so if you remember this, more or less you can easily remember what is Fourier sine and cosine term. Okay, so in general, if I just write down that, let's say fx is even, so if fx is even, you will see that this is even, this is odd, so this term will vanish. I'll be left out only with this particular term, right? So if I'm left out with this particular term, what I can do is I can simply write it down as fk is equal to 1 divided by root over of 2 pi, and this is an even term because fx is also even, I'm saying. So that means I can just take out a 2 here, and then this will be nothing but 0 to infinity cos of kx fx. This is a Fourier cosine transform. Okay, Fourier cosine transform. So Fourier cosine transform, I'll just write it down. Let me write it down in a separate folder, maybe it. Fourier cosine transform is FC. I'll just put an C there at the bottom just to denote that this is the cosine transform, is equal to me just even modify this. 2 by pi. In a lot of books, directly you'll get this answer. It's 2 by 2, root over 2, right? 2 by root pi. So root 2 by root pi, I will get this as 0 to infinity fx cos kx dx. This is your Fourier cosine transform. Please remember this. Okay, this is one. And then if fx is odd now. So if fx is odd, this term will vanish because one is odd, one is even, and this is odd. That means this is odd, this is odd. This term will actually survive, right? So in that way, you can actually get a cosine term. So let me just write it down directly. So it will be f, let's say sine term, not cosine term, sine term. Sine transform is equal to root over of 2 by pi. This is a good way to remember in case you forget it. But sometimes there are special cases. It's difficult to determine whether it's an odd function, an even function, and then you have that complication. So you have this kx dx. Okay, so this is your Fourier cosine term. Oh, sorry, sine term, FST. So I'll just write it down as FST and FCT. Okay, so with this I will actually try to just list down the terms here, which is important. So Fourier sine transform. Please remember these, is important. FSK it is equal to root over of 2 by pi into integration 0 to infinity fx sine of kx dx. Okay, and then if you take the cosine term fck. So you have to make these tables very important, because whether be it in this exam or competitive exams and all, you really don't have time to sit and solve and then remember it. It will be difficult. So it's important that all of us kind of remember these results. Kx dx. Okay. If we have a sine term, we should also have an inverse. So inverse Fourier sine term. To remember this, f is x, inverse k becomes x, right? This will remain as root over of 2 by pi, not an issue. And then we'll have it from 0 to infinity. Fkx will become fs. Okay, and then sine of kx dk. Okay, so remember this is fx, so x will become k, sorry, not s. Okay, so this is the inverse. So similarly, I can also have inverse Fourier cosine transform, and here I will have fc of x here is equal to root over of 2 divided by pi integration of 0 to infinity f of k cos of kx dk. So you have to remember both the Fourier sine transform as well as the cosine transform along with their inverse. Okay, so that is important. So if you just take up sum, we'll just do it fast. I know you can do it also, but then I'll just do it as an example so that all of you understand. Right? All of us understand how to do it right. Very important. So I'll just take an example. Okay, very simple example here. How to use it. That's it. You already know now that you have to basically just do your integration properly, and then you should be able to get your answers. Find the Fourier sine transform and Fourier cosine transform. Okay. cosine transform, and the function is fx is equal to 1. Okay, now x1 lies between 0 and let's say a. We can take it from minus infinity to plus infinity, but then it exists only between 0 and a. Everywhere else it is more or less 0. Okay, x greater than 0 is 0. So I can directly take the Fourier sine transform fst. I'm using determinative fst. I'd prefer you not writing down fst in your exam. Maybe in the first line you can write it down Fourier sine transform. Within bracket you can write down fst and then keep writing it. Not a problem there. Root over of 2 by pi. So we are using this relation here. And then it's integration, and then you can go from 0 to infinity, but then effectively it's just 0 to a. I'm just directly putting it. Fx 0 to a, it is nothing but 1. So it is 1 here, and then we can just take out the sine kx dx. So just just practice. I think that's all that we need. It's fun, when you understand maths, when you understand the steps, when you know your integration results, differentiation results, solving numerical problem is always of 0 to a. Right? So you can just take out this minus sign, and then this will be root over of 2 by pi, and then maybe I can just directly write it down, right? It will be 1 by k, so I can take probably k as the LCM here, and then it is cos of ka, right? Yes, I have taken it out, so upper limit is there, cos of ka. So cos of AA minus cos 0 is 1. Right? That is 1. So that's your answer. Okay, so that's your Fourier sine transform. Similarly, you can do your Fourier cosine transform, right? So FCK. So this is just take this as an example, okay? Don't take this too seriously. If I'm in a good mood, I might just put this question because this is one of the easier ones. Cos of kx dx. So if you just solve it, this will be root over of 2 by pi, and then this is nothing but fx is 1, so this is s sine of kx divided by k 0 to a, so I just replace that. Should be a root over of 2 by pi. No, sorry. It should be sine. This sine of a by k. That's it. So that's your Fourier sine transform and cosine transform. Okay. So that's again important. And you can actually use this idea of separating out e to the power ix into cos and sine term, and then actually solve some problems. So maybe I can take a problem which may be a bit more complex than the previous one. This is this. Let's take this example. Fx is equal to e to the power minus ax. Okay. And a is greater than or equal to 0. This is there. You have to show that. I'm not asking for Fourier sine or cosine transform, but finally you are going to use Fourier sine and cosine transform 0 to infinity, and then x sine. The approach is more or less the same what we did in the morning class, in the class before that, okay? But then here we are going to use the sine and the cosine transform. Dx is equal to pi by 2 e to the power minus am.
Hello, sir.
Yeah, tell me.
Please tell me first thing, that means 0 to infinity x into sine mx or
Mx. It is mx divided by x square plus a square into dx is equal to pi by 2 e to the power minus an. Okay, and the second relation is cos of mx, okay, divided by x square plus a square dx is equal to pi divided by 2 times of a e to the power minus a n. A lot of things are common here, and then we can do it. Okay, let's try solving this. Okay, you will have enough tasks to do, so these problems we can just take an example. That's important. Fourier sine transform, we can just take up this fs or fk, whatever. Just put an s here. So is equal to root over of 2 by pi integration 0 to infinity fx sine of kx dx, right? So this is root over of 2 by pi integration of 0 to infinity. Now this is e to the power minus ax, so I'll just keep it as e to the power minus ax into, we have got it as sine of kx dx. Okay, so this is the relation that we actually have. But no, if you want to solve it, you are going to use series, and then you're basically trying to solve it and so on. So for that purpose, we actually need to remember certain important integrals. Okay, that is what I'm going to give you now. And this is again you need to remember. Else, if you want to solve it entirely, it's going to take a lot of time. So if you have it like this, let's say 0 to infinity e to the power an. These are some standard integrals that you should remember. X dx. Okay, this is also a part of a standard integral variable.
It to the power en or ex.
E to the power ax. Sorry, which one? Which one you're saying?
Integrate it to the power ex. Yes, sir.
You're talking about this one?
Yes, sir.
Okay, just wait. Let me check. Yeah, it should be ex, I guess. Yeah, e to the power ax. We have it, so we'll be using that integration sign. Yeah. Let me check the question first. Now, just wait. Question is okay. Yeah. Oh, sorry. I think it should be x. Okay. Yeah. So e to the power ax divided by a square plus b square into a sine bx minus b cos bx. So this is one result that you should remember, and one more is 0 to infinity e to the power ax cos of bx dx. So this is again e to the power x divided by a square plus b square is a cos bx plus b sine bx. Okay, so these are some important results that we should actually remember, and we'll be using this result to actually solve this particular problem. Okay, just look into it. Okay, let's just have a look into it. Okay. चलो इसमें बॉक्स में डाल देते हैं, कंफ्यूजन नहीं होगा. Okay. Not so pretty, but still fine. Okay, so we can just do this. Okay, we can actually adjust this accordingly, and then what we can do is we can write it down as root over of 2 by pi, and there is a minus there, so we can just replace it accordingly. It's with the sine term, so we are going to take this first result. So e to the power minus ax divided by a square is fine. Yeah, but a square is fine. Okay. and you don't have, a square is fine, and then you have got plus, and this is b. This is b here. That means this is k here. So just write it down as k square. Just replace it accordingly. That's it. Okay. And then we can just take up, x minus should be there. Okay. There will be a minus here. We're not going to do it, but then if you place sine minus x is minus sine x, so you can understand. A sine kx, cos of minus x is cos x, so the minus survives here. B की जगह k है, and then we'll take it to be cos of kx. I hope this is correct. Yeah. Okay, and then you can do the 0 to infinity. Okay. So if the limit is not there, sorry, I think we should put this here. 0 to infinity, 0 to infinity. Put the limit. Okay, without the limit, it's given just without the limits we have. So it's basically nothing but indefinite integral terms. Okay. So put the limit now, and let's see what we get. So it will be root over of 2 by pi. Okay. Let's just have a look. Okay, what happens here? So this is infinity, e to the power minus infinity, right? E to the power minus infinity. It can be written as 1 divided by e to the power infinity. It can be written as 1 divided by infinity, which is equal to 0. So if you put the upper limit, everything is more or less going to be 0. So I'm really not concerned about it. I'm just going to take out the lower limit, right? If you put the lower limit, let's see what happens. I think we can also see that if you put the lower limit, this term will become 0. So the only term that survived is this and this, right? So first upper limit will be 0. So this you have to do it verbally or mentally, okay, mental math. And I think you can do it. Should not be difficult. I should understand that you have done it. E to the power minus ax, I put 0, so it is 1, so it's fine here. Put a 0 here, sine 0 is 0. And minus cos of 0 is 1, so we'll just k, that's all is here. So we'll have it here. So in general, I will have it as root over of 2 by pi into k divided by a square plus k square. So I found out what is the Fourier transform, okay, Fourier sine transform. Now what we will do is we'll find out the Fourier inverse sine transform, right? And then only we can show it in this way, okay? I hope you understand it because we have it here. So in these kind of problems, you have to find out the transform first, and then you have to find out the inverse transform first, okay? And then use whatever result you got in transform in the inverse transform, and then finally you are going to land with your answer. Okay, so let's try. Okay, so now I'm going to use inverse transform here by inverse Fourier sine transform. Okay, let's see what we're getting here. So it's going to be fs and x here on this side is equal to root over of, when you do these sums, it will take some time, but then the marks are solid. You get it correct, get the marks. That's what is important. And this is fk sine of kx dx, sorry, dk. Right? So don't make the mistake of dx and dk. I do that sometimes, okay? So you have to be careful. That's why if I'm doing any kind of error, do correct me. It's important. Then I'll take it from 0 to infinity. That's fine. And what was my fk? My fk, which is the Fourier transform I got in the previous page, it was nothing but 2 divided by pi into k divided by k square plus a square. Okay. And we have got the sine kx dk. I'm going to take this fs or f of x on the other side. Okay, I'm just going to write it down as e to the power minus x. So as soon as we write it down, we know that we are going to just do some kind of adjustments. Finally, we are going to get our answers, right? So this multiply, it will be nothing but 2 divided by pi, and then I will take it from 0 to infinity, and then this is k sine kx divided by a square plus a square dk. is equal to e to the power minus ax. So whenever you are doing these kind of sums, you have to just keep in mind that what is the final result that I want. I want sine x sine mx. Okay, x sine mx. That means you have to basically take some changes here. Okay, so what I can do is first thing I can take x is equal to m. You have to just foresee whatever can be the possible answer. Okay, you have to just predict a lot of things here. Let's put x is equal to m, and there is no dx term, so I don't need to worry much. 2 divided by pi, and then this will be integration of 0 to infinity. This is k sine k of m divided by k square plus a square dk is equal to e to the power minus am. So slowly we are getting it, okay? And then I think you can easily guess. You can put k is equal to x. These are all variables. You can just change. Is equal to x. dk would be equal to dx. So if I just write it down on this side, this is 0 to infinity. This is x sine kx divided by a square plus a square, and dk is equal
Sine
to
mx.
dx. Yeah, sorry.
Sorry, mx and m square as well.
Why should there be n square?
X
We'll
square as
just
well.
why? Below of course.
Yeah, sir. Here, k equal to x square. K square q.
K is nothing but x, so it is x square plus a square, right? Yeah. Dx is equal to 2 by pi, so take it on the other side, pi by 2, e to the power minus a. That's proved. So, this is something which will come to you naturally. It will be very mechanical. If you just practice, more you practice, you're going to get the answer. So now I think you can easily guess how you're going to do the second one, which will be actually nothing but using the Fourier cosine transforms.